Alright, so in this video we're going to start a little logarithmic warm-up with some evaluations. And I'm evaluating these logarithms. I've got 4 that I've prepared here. 1, 2, 3, 4 here, without calculators. So when it says without calculators, that's a big clue to how you should be approaching these things. Basically, you always transfer it into an exponential equation, or in other words, convert it to an exponential equation. And the way you can think of that is, let's take this first one. I've got log base 3 of 1/9. And I want to know what that is. So when I say evaluate it, you can write in an equals x, and we're trying to figure out what x is. Now, if we turn this into an exponential equation, what is that? That is 3 to the x equals 1/9. And here's the thing about evaluating logarithms by hand. You know the bases are going to be equal. Okay, it's just a matter of figuring out what the exponents are. So this 1/9 here, I can rewrite that as 3 to something power. Okay, we just have to figure out what that power is. And you guys know that 3 squared equals 9. So that would make sense that 3 to the x equals something about 3 squared. Some way of doing 3 squared makes it 1/9 instead of 9. And this is where negative exponents come in. So if 3 squared is 9, then 3 to the negative 2, that's 1 divided by 9. So I'm looking at 3 to the x equals 3 to the negative 2. And since the bases are equal, these 3's, that means the exponents have to be equal also. It's the principle of exponential equality. So that means x equals negative 2, which is the answer. This logarithm then evaluates to the following. Log base 3 of 1/9 equals negative 2. Okay? Likewise, for all these other ones, let's start with log base 25 of 125. So in this case, and let's just give me a little more room here. In this case, I'm going to start with this as an exponential equation, right? I'm going to say equals x, and then I'm going to turn it into an exponential equation of some kind. And we'll say 25 to the x equals 125. And I know they have to have equal bases because I'm being told to do it without a calculator. But if you think about what 25 raised to the 1 is, that's just 25. But 25 raised to the 2, if you punch that into your calculator, you're going to get 625. So it doesn't look like there's anything we can do at this point. But try to remember something about 25. It's not just 25. We could also write that as 5 squared, right? 5 squared to the x. And if you think about it that way, now we can make something of this, because 5 to the 1 is 5, 5 to the 2 is 25, 5 to the third power is 125. Bingo, this is the one we want. So we're going to write the left side as 5 squared to the x power, and the right side as 5 cubed. Okay, so now we just have to figure out how to work this out. When you have an exponent, like you do on the right, raised to another exponent, you multiply the exponents together. That's the product rule of exponents. So we get 5 to the 2x equals 5 to the 3 power, right? And I used the product rule there. I'm sorry, that's not the product rule. That is the power rule. Okay, exponents raised to exponents. You multiply them together. So the bases are equal. That means 2x equals 3, which means x equals 3 halves. And that means, since we were solving for x in the beginning, that our problem log base 25 of 125 equals 3 halves. Okay, let's move on to another one. In this one, we have log, and it doesn't tell us what the base is, but the logarithm of the cubed root of 100, what is that? So just remember, anytime you see a log where there's no base identified, what that means is log base 10. It's just shorthand. So now we've got an equation to evaluate here. We're going to say 10 to the x equals the cubed root of 100. And I know I'm going to have to express everything in terms of the number 10, right? So maybe we could write it this way. Let's say 10 to the x equals the cubed root of 10 squared. That's 100. Well, now look at this. The cubed root of 10 squared can also be written this way. 10 to the 2/3. Okay, this is the way radical signs can be rewritten using fraction exponents. So now if 10 to the x equals 10 to the 2/3, that means x equals 2/3. And what that means is the logarithm of the cubed root of 100 equals 2/3. That's the answer to this question. And the last one I pulled in here was natural logarithm of the cubed root of e squared. Well, if you look at this, you'll see a similarity between this problem and this part of the previous problem. Right? In the last problem, I had 10 to the x equals cubed root of 10 squared. And in this problem, once you rewrite it, remember natural log? Remember what that means? That means log base e. That might clear this up a little bit. Okay, so if I rewrite this as an exponent, it's going to say e to the x equals the cubed root of 10, not 10 squared, I'm looking at the previous problem, e squared. So e to the x equals the cubed root of e squared, which by the same reasoning as in the last one is, I keep getting stuck on 10 here, is e to the 2/3, which means x equals 2/3, which means the natural log of the cubed root of e squared equals 2/3.